So now that we've gone through the basic approach to acid-base disorder questions, let's quickly summarize them. The 4 acid-base disorders are respiratory acidosis, respiratory alkalosis, metabolic acidosis, and metabolic alkalosis. So first we look at the pH, which should be between 7.35 and 7.45. If it is less than 7.35, this is an acidemia. If it is more than 7.45, it is an alkalemia. Next, we take a look at the bicarb and carbon dioxide levels. If there is an acidemia and the partial pressure of carbon dioxide is less than 45 millimeter mercury, this is a respiratory acidosis. And if there is an acidemia and the bicarb levels are less than 20 millicurie per liter, we are looking at a metabolic acidosis. If we have an alkalemia and the partial pressure of carbon dioxide is less than 36 millimeter mercury, we have a respiratory alkalosis. And if we have an alkalemia with a bicarb level of more than 28 millicurie per liter, we have a metabolic alkalosis. Metabolic acidosis is further divided into 2 more groups that are anion gap metabolic acidosis and non-anion gap metabolic acidosis. But this will be covered in a separate video, as well as the causes of each of the disorders. So keep a lookout for those. Now, to summarize the compensation. It is important to remember that the respiratory compensation is fast, and the metabolic compensation occurs later on, and so is slow. For metabolic acidosis, we use the Winter's formula to calculate the expected carbon dioxide for compensation. Next, we have the metabolic alkalosis and the equation to calculate the expected carbon dioxide change. For respiratory acidosis, we can remember a rule of thumb for acute compensation being 1 millicurie per liter increase in bicarb for every 10 millimeter mercury increase in carbon dioxide, and in chronic compensation a 3.5 millicurie per liter increase in bicarb for every 10 millimeter mercury increase in carbon dioxide. Last, we have the respiratory alkalosis, which can be remembered as acute respiratory alkalosis with 2 millicurie per liter fall in bicarbs for every 10 millimeter mercury drop in carbon dioxide, and for chronic respiratory alkalosis with a 4 millicurie per liter fall in bicarbs for every 10 millimeter mercury fall in carbon dioxide. The most important of these at the student level is the Winter's formula, so make sure you know that one. So now we hope that this video made acid-base problems easier to solve. Remember that the best way to get a grip on these, like anything else, is practice. So for more videos like these, keep watching sqadia.com.